Convert the decimal number 75 base 10 to each of the following equivalents. We have to change it to binary, and we have also to change it to gray code. So we start with Roman 1. We change it to binary. So when we change base 10 to binary, we can use the method of repeated division by 2. So we divide repeatedly with the 2, then we write the binary number formed by the reminders. So we have 75. So here we have the remainder. So we have to divide by 2. 75 by 2 we get 37. And the remainder here is 1. We have the remainder as 1. Then we divide by 2 again. We get 18. The remainder becomes 1. We divide 18 by 2. We get 9. Remainder is 0. We divide 9 by 2. We shall get 4. Remainder is 1. We divide 4 by 2. We get 2. Remainder is 0. We divide 2 by 2. We get 1. And the remainder is 0. We divide by 2. 2 goes in 1 0 times, and we remain with the 1. So we have divided 75 repeatedly by 2. And we have written the reminders in this column. So after that, the binary equivalent is written from the bottom upwards. So the binary number here will be equal to 1001011 base 2. So that is how we change it to binary. Let's change it to gray code. So when you are changing to gray code, you take the binary equivalent and XOR each binary with its next binary number to get the equivalent gray code. And this is the general equations that we use. So when you XOR, for example, we have 1. When we XOR 1 with 1, we get 0. When we XOR 0 with 0, we get 0. 1 XOR 0 is 1, and 0 XOR 1 is 1. So we use this to get our gray code. So when using our binary number, we shall be XORing 1 and 0. Then we go next with 0 and 0, 0 and 1, 0 and 1, then 1 and 1. So we have 1 XOR 0. We are using this. We have, this is 1. 0 XOR 0 is 0. We move next with 0 and 1. So 0 and 1, we get 1. 1 XOR 0, we get 1. We have next is 0 and 1, we get also 1. And lastly, we have 1 and 1. 1 and 1 is 0. So the binary that is formed is this one. So the equivalent gray code of 75 base 10 will be 10, that is 1 0 1 1 1 0. That becomes the solution.